Good morning, all of you. So today we are going to look at a practical Kubernetes in 2 hours. In the very first video, we have demonstrated how we can basically create a lab environment setup so that we can run a single node minikube Kubernetes cluster, right? So we have done that. And before we really move into the practical demonstration, I think I will take another couple of minutes to really complete some of the concepts which will be very, very key. So although we are definitely focusing on the practical aspect, so this will be very, very brief. So let me go on with this. So you can see that when we are trying to use the container runtimes, so when we try to use minikube installation lab setup for us, so we have used Docker as our runtime. So you can see these are certain examples of the runtimes if we are trying to create any kind of the Kubernetes cluster. So if we are trying to draw an analogy from the Docker, inside the Docker, as you might understand that the container is the smallest anatomical unit, and in Kubernetes the pod is a single smallest anatomic unit, right? So you can see that in the pod you can have single container or multiple containers. You can also have shared volumes or shared IP addresses. However, so now giving an example of the Kubernetes cluster. So you can see a Kubernetes cluster basically comprises of one node or multiple nodes, and these particular nodes can be deployed across multiple servers or multiple EC2 instances across the region or in different availability zones. But however, it is recommended that your node should be deployed in a single availability zones, so that they can communicate even more efficiently. One particular node comprises of many pods, and as we have discussed, pod is the smallest anatomical unit. It might contain several or multiple containers, but however the most common use case is single container within the pod. So pod will always constitute in a single node or in a single server. uh, so this is how the Kubernetes cluster looks like from the bird eye view. So talking about within Kubernetes cluster, we have a concept of master nodes as well as worker nodes. So master node is something which basically runs a system pods, which are quite essential for the effective functioning of the Kubernetes. And in the worker nodes, we can basically deploy or create multiple containers or multiple pods, depending on our use case requirement. So as I suggested, this is the most common use case, one container per pod. However, we can tie different containers in one particular pod if the use case is such. Talking about some of the Kubernetes services, so we have discussed something about master node as well as worker nodes. So in every node, you have some of the three essential components which you can see on the screen. So kubelet, just think that particular thing as of agent. If you have heard about CloudWatch agent in AWS EC2 instance or systems manager in the AWS EC2 instance, so it's just like a sensor, which basically communicates with the API server in the master node, right? Then there is something known as kube proxy, so which is basically responsible for all the networking related constructs. So if you have heard about the ClusterIP is getting assigned to your workloads, or LoadBalancer for that matter, or NodePort. So all these network constructs are being managed by the kube proxy. We also discussed about container runtime, and in our environment we are basically using Docker as our runtime, but there are other container runtimes which we can make a use of. So talking about master node, we have some other essential components starting from the API server. So API server, so all the sensors are basically communicate with the API server. All the kubelet agents in all the worker nodes basically communicate with the API server with the help of what we call it as REST APIs. And then we also have something known as a scheduler. So scheduler is basically responsible if we are deploying pods So scheduler takes a decision in which particular nodes pods should be deployed if we are trying to scale up or scale down, right? So it basically takes that decision. So that is scheduler. Kube controller manager, it basically controls every aspect what is happening in the various nodes within the Kubernetes cluster. Then we also have cloud controller manager. So if we are talking about EKS in AWS, so if we really want to communicate with the cloud provider APIs for creating, let's say if we are trying to deploy our nodes in the EKS cluster, so some kind of the communication has to happen with the help of the cloud service provider APIs. So it can be done via cloud controller manager. And also one of the networking construct you have heard about is load balancer, which can be fronted by the various your container runtimes or nodes for that matter. So those kind of the load balancers can be deployed with the help of cloud controller manager, right, which will be front facing as compared to your runtime workloads. Then we also have something known as TCDs. So etcds, all the logs corresponding to your Kubernetes cluster will be stored into the etcds. So it is one of the essential services. So this is pretty much of some of the theory which might be little essential, and then I will see you in the next video where we will be getting started with a practical demonstration of everything which we have mentioned on our agenda. So see you in the next. Thank you. So in this particular session, we will be looking at creating cluster using minikube and also exploring K8 nodes. So without any delay, I will be shifting to my terminal. So just give me a sec. So I'm running two EC2 instances. So for example, you can see that if I can make it a little bigger, I have already done minikube start. So you can see that a kubectl is now configured to use minikube cluster and default name. So if I go to the another terminal, I just wanted to show you a minikube status. So just remember, if you haven't really done the setup which I have demonstrated in the very first video, so just refer the video practical Kubernetes lab setup. So I think you will be good. And so if you are here, if I try to run the command minikube status, you can see that API server stopped, kubeconfig stopped. So before any if you check the current status and it is already stopped, so you can basically make the use of minikube start. So if I do that, your cluster will be up and running in some time. So it might take some time. So because it might be taking some time, that is the reason I am shifting to the different terminal. So let me clear my screen. So the second thing I just wanted to tell you here, if you run minikube status, you can see that host running, kubelet running, API server running, and kubeconfig already configured, right? So now we would like to minikube IP. So if I run this particular command minikube IP, we will retrieve the IP address which is corresponding to your node, right? So if I do that, you can see that this is the IP address which is assigned to our single node, which is nothing but minikube. And I can also run one more command, kubectl cluster info. So you can see that again we have retrieved the IP address corresponding to our minikube node, and you can also see there are certain services which are running, just like core DNS and something of that nature, right? So now since our cluster is up and running, so let's try to get familiar with the nodes. So for example, if I do one more second, minikube, so this is the IP address, right? So if I do kubectl get nodes, so you can see that this is the node, right? So since this is our single node Kubernetes cluster, we can see that this is one particular node in our Kubernetes cluster. So now if I try to retrieve what are the pods which are running, so at this point in time, I have not really created any kind of the pods, so we should not be seeing any kind of the results, right? So now let's try to list some of the namespaces. Kubectl get. So NS is nothing but the shorthand for the namespaces. So you can see that there are 4 namespaces: default, kube node, lease, kube public, and kube system. So if I try to run this particular command get pods, so by default it will be trying to list all the pods which are there in the default namespace, but I can also instruct. So for example, let us try to retrieve the pods which are running for this particular namespace, which is nothing but kube system. You can see that so these are the pods which are corresponding to the system pods. These are not our application pods. So these are some of the essential pods which are running in our master node, right? So which are quite essential. So these are all the essential services. So in the previous video we have talked about some of the essential services in the Kubernetes cluster in the master node. So for example, we talked about TCDs, we talked about API server, controller manager, proxy, scheduler. You can see all those pods which are essential for those services are already there in the namespace namespace known as kube system. So let me try to clear my screen. So kubectl. So if I do this particular command, by default it will be list all the pods which are running in a default namespace. So for the subsequent sessions we will be using the default namespace for us, and so this is what I really wanted to cover in this session, and see you in the next. Welcome to this section, friends. So we are looking at pods creation, and you can also see in the slide that we are basically looking at these particular commands. So without any delay, let me get back to my terminal. So this is my terminal. Let me clear my screen. So yeah, so at this point in time I just wanted to show you that there is no pods running as of now. So you can see that in my default namespace there is no pods running as of now. So let us create our very first pod. kubectl run, I would say nginx. So nginx is the name of the pod we are going to specify, and I will be specifying image. I will be specifying the image as, just give me a sec. So this is the image we are going to specify, nginx, which will be getting pulled from Docker Hub as a repository. So let's do that. You can see the message pod nginx created. So if I try to list any pods, you can see that this is the pod nginx. So if we do not really explicitly specify our namespace, you know that that particular pod basically belongs to the default namespace. So now our pod has already been created and started running. So let us try to describe this particular pod. kubectl, I would say describe, I would say pods nginx. So yeah, so just give me a sec. So I just wanted to show you what we are getting, so for example, if I try to describe pod nginx, you can see the namespace is default. So if we do not explicitly specify the namespace, it will be getting created in a default namespace. And for the rest of our course, we are going to use default namespace only. And you can also see that this particular pod is running on the node, which is nothing but minikube, and you can also see the corresponding IP address of our minikube node. So you know that minikube is nothing but a single node Kubernetes cluster. So we have only one node as of now, and in which pod has already been created with the name nginx. You can also see the labels. So labels is nothing but run nginx. And you can see the status. You can also see this is the IP address that has already been assigned to the pod which is running under the node minikube, right? And if I scroll down, you can also see the container ID. So it's quite same as if we try to create any kind of the container with the help of the Docker. And you can also see some of the details that this particular image has already been pulled from the Docker Hub repository. So if I scroll down, so there are certain other informations. So this is what I really wanted to show you. What is the information that is available if we try to describe the pod. So just let me clear my screen. So now what I really wanted to do is, so now we know that our node is a minikube and in which pod is running, right? So for example, if I try to docker get pods, kubectl get pods. So you can see this nginx pod is running. So what I really wanted to do now is, again, I try to list minikube IP. So the IP address which is assigned to our node. So this is the IP address. So I just wanted to SSH to this particular IP address. So just give me a sec. So if you are following along and if you have the same setup as that of myself, which I have already demonstrated in the very first video, and I will try to SSH. So you can see that this is 49.2. This is nothing but the IP address assigned to our single node. So if I do this, so you can see that I have already logged in into my node. Yes. So for example, if I try to see Docker PS, so it will list all the containers which are running, or all the pods which are running inside my single node. So it also comprises of all the nodes which we have seen related to the kube system as a namespace. So all the pods which are running on the master node as well, right? So better way of doing it is if I try to do, let's say, Docker PS, and I would grep, because we are only concerned about our pods, nginx. So you can see that it has given me the list of 2 pods which are running as of now, and the second one you can see the pause against that particular pod. So what happens is, for every pod which we are creating, there is a pause pod which is getting created. The sole purpose of this particular pod which you can see here, which is already paused as of now, is to allocate the namespace for the pod which we have requested so far. The pod which is above, so this particular pod, the default namespace has already been assigned. So this is the purpose of the pod which is listed just below that. So it is no longer running as of now. So I just wanted to show you that. So apart from that, if I go back to my so this is what I really wanted to show. And now since we have already listed, this is the container ID, you can see this is the container ID. So let's get inside this particular container ID for a bit. So I would say docker exec -ti, and I would be taking into account this container ID, and I would say sh. So now I am inside my container, or now I am inside my pod, right? So for example, if I try to do host name, should see nginx. Let's try to list our IP address which is getting allocated to our pod, right? So this is the IP address corresponding to the pod which is running as of now. So 172.17.0.3. So this is the IP address. If I try to curl, since we are basically making the since we are basically making the use of nginx as a Docker image which is getting pulled from Docker Hub repository, this is the web server. So let's try to curl our web server. Just a second. So I would say 172.17.0.3. So you can see that I have got the output because our nginx server is up and running, and I can see this message, welcome to the nginx, So let's try to exit from the pod. So if I exit from my pod, now I have gotten back to my node, which is nothing but minikube. You can see minikube is our node. So let me clear my screen once again, and if I try to do host name once again, host. So you can see that I am on my node as of now. If I try to do the curl once again, 172.17.0.3. So you can see that again I have got the message, welcome to the nginx. What I am trying to demonstrate here is we are trying to establish connection to our pod from our node, and we are successfully getting our output of our curl command, which is nothing but welcome to nginx. So from the container itself, or from the node, from the pod itself and from the node itself, I am successfully able to establish connection to the pod. That's what I wanted to say. Now what I wanted to do is I will clear my screen, and I am exiting from my node, which is minikube. So here I have logged out successfully. So if I do host name, so now I am back to my Linux machine, right? Sorry about that. So this is my Ubuntu machine, right? So this is my Ubuntu machine. I have gotten back to my machine, and the minikube is basically running as a virtual machine on my base machine, right? So that's what I wanted to say. So if I try to do curl, my bad. Again, I will be making the use of 172.17.0.3. So from my base machine, I will not be able to establish a connection to the pod which we have successfully established from our node and from the pod itself. You can see that we are not able to establish a connection. So for that, we basically make the use of the service which we are going to see in the subsequent demonstrations. So that's it. See you in the next. Thank you. Hello everybody. So in this particular section, we are basically looking at deployment creation. So we have already looked into the pod creation in the previous video. So let's get started with that. So let me move back to my terminal. So when I try to kubectl get pods, so this is the pod which I have created by by single-handedly creating a pod itself. I have not really created a deployment in the previous case. So what is the advantage of creating pods with the help of the deployment? So subsequently we can scale up and scale down and manage all the pods as a part of the deployment. So deployment definitely holds an advantage. So we should not be creating pods single-handedly. So let's get into that, how we can create a deployment. So just give me a sec. So for example, the first command I'm going to run is, so this is the command. So kubectl create deployment. So just give me a sec. So I made a kubectl create deployment nginx deployment. So nginx deployment is nothing but the name of the deployment which we are giving to the deployment which is getting created. And the image, again, we are going to refer to the image or Docker image that is getting pulled from the Docker Hub repository. So let's do that. So you can see that we have created a deployment. So let's kubectl. So if I try to list the deployments, you can see that we have created successfully the nginx deployment, right? So let's try to, now I will try to list the pods once again. So I will go to get pods. So you can see that when I try to list all the pods which are running as of now, so you can see that the very first pod, which is the name nginx. So this is the pod which we have created single-handedly. We haven't really made a use of the deployment. The second pod which is running as of now, it is created as a part of the deployment and it is being managed by the deployment, right? So let's try to see the property of this particular deployment. So I would say kubectl describe deployment nginx deploy. So let's try to walk through what are the properties that are associated with the deployment. So let me scroll up. So in a second. So you can see the name of the deployment is nothing but nginx deployment, which I'm trying to highlight here. And again, the namespace, if we have not really specified any namespace, it is going to get created in the default namespace. You can again see that this is the label which is associated with the current deployment, and you can also see selector. So this particular label, so just remember that the pods and deployment, these are the different objects within the Kubernetes. So selector is one of the attribute which is basically trying to associate a pod into one of the deployment. So you can see that the pod which we have created is getting associated with the current deployment which is named as nginx deployment. At the same time, you can also see the replicas. So when we try to create a deployment, we haven't really specified replicas. So by default, it will be one. So by default, there is one pod which is getting created as a part of deployment. Strategy type is rolling update. So we will also look into the rolling updates in the subsequent demonstrations. Then you can also see the pod template. So the image, we are basically making the use of nginx Docker image, which is getting pulled from the Docker Hub as a repository. So if I scroll down, so you can see that again, so there are certain events associated with the deployment. So which we are seeing scaled up to replica set nginx. So there is one pod which is getting created as a part of deployment. So let me clear my screen and I will go back to my notepad file once again. So we have so let's try to see the property of pod also before we will move on. kubectl describe, I would say pods, I will say nginx deployment. So if I scroll up, yeah, so if I scroll up, you can see that this is the name of the deployment. You can see this is the name of the deployment. Sorry, the very first attribute is referring to the name of the pod. So the the uh, the thing which I'm highlighting as of now is basically corresponding to the hash of the deployment which we have created already, and this particular hash is basically associated with the pod itself. Again, you can see the namespace, which is nothing but default namespace. So this is a single node cluster. So again, you can see that this is our single node, which is nothing but minikube. If you see the labels, you can see that this is the hash which is getting associated with the deployment which we have created, and the same hash is also there in the name of the pod also. And followed by that, there is a hash which is corresponding to the pod which is getting created as a part of the deployment. And similarly, you can also see that this particular pod is controlled by the replica set, which is nothing but nginx deployment, and this is the hash which is corresponding to the deployment which we have created. So this is what I really wanted to show you. So before I clear my screen, now I will try to show you how we can really scale the deployment, right? So let me copy this particular command. So let's try to scale our current deployment. So you can see that now kubectl get pods. If I try to create a pods, you can see that since all these particular pods are managed by the single replica or single deployment, you can see that the name is same. You can always see that this is the hash which is corresponding to the current deployment, and followed by that you can see something different. So these are the hash which are corresponding to the pods which we have created just now. So if I can also, let's say, so I will try to list the pods once again. So you can see the status is running for all the pods. At the same time, you can see the name of all these particular pods which I have just explained as of now. At the same time, you can see that these are the IP addresses which are associated with the pods, right? So remember that we are basically making the use of the single node, which is nothing but the minikube, and this is the single node Kubernetes cluster. And therefore, when we try to scale our pods, all the pods will be getting deployed in the single node, in the same node. But however, if our Kubernetes cluster comprises of the different nodes, your scheduler will take a decision in which particular node we should be deploying the pods. So it might differ in that particular case as well. But for our case, we have the single node, and therefore all the pods are getting deployed in our node, which is nothing but minikube. So let me clear my screen. And similarly, if I really wanted to scale down my deployment, so I can again mention this particular command. So it will basically, so if I try to, you can see that, so the first one is again the pod which we have created single-handedly, which is not really a part of deployment. And now we can see that the other two pods are already getting deleted. Now the number of the pods which are associated with the deployment is 3. So this is what I wanted to cover. Thank you. See you in the next. Hello guys. So in this particular section, we are going to look at service creation. So before I explain service creation, I just wanted to show you a little bit of the demonstration what we have already seen before, but just to revise that. So before I do that, let me clear my screen. So kubectl get pods, and I would rather do this one. So you can see that there are certain IP addresses 3456. So these are the IP addresses associated with the pods which is running as a part of the deployment which we have seen in the previous demonstration, right? So let me clear my screen. So I just wanted to explain the pods which are a part of the deployment, and these particular pods are basically making the use of nginx as a server. So I just want I have demonstrated, so let me again. So for example, at this point in time, I am in my base machine, which is nothing but Ubuntu. So for example, if I try to do curl, just give me a second. If I try to do curl 172.17.0.3, I will not be getting any result because the pods are not really reachable from the outside. So you should be you can only be connect to the pod from your node, not outside world, right? So I am into my base machine, and in this particular base machine, my minikube single node cluster is running as a part of the virtual machine. So from my node, these particular pods will be reachable, but not from the outside, not from my base machine, which is Ubuntu, right? So you can see that I haven't really gotten any kind of the response. So now what I really want to do is, just give me a sec. Now I just wanted to log in to my node, right? So I think I have already made a use of this particular command. So I'm just logging into my node. So you can see that I have already logged in into my node, which is nothing but minikube, right? So if from here, if I try to do curl for any of the pods, so let's say curl 172.17.0.3. So you can see that I have gotten the response back, which is nothing but welcome to Nginx. So I have got 3 pods running as a part of the deployment. So this is the response sent by one of the pods, which I can't identify at this point in time. But I just wanted to show you, my pods will be reachable from the node, right? So for example, just give me a sec. So here I am here. I have already logged in into my single node, and I am getting the response of my curl from one of the pods. So this is what I want to show you. So let me get back to my base machine, which is Ubuntu. So here I already tried curl, and I have not really gotten any kind of the response. So and also I just wanted to show you. So for example, let's say I will try to list the pods once again. So if we try to focus on all the pods which are created as a part of the deployment, right? So it will not be practical to really reach out to one of the pods, right? So for example, we can basically make a use of ClusterIP. So ClusterIP can be assigned to our single node, or the node which is basically running all the pods. For example, our minikube, right? So we can assign a cluster IP address, and if I try to do the curl, and then I will be getting a response back from one of the pods. So this is one of the way of doing it, and this is why we are basically creating a service. So let us try to do that. So hopefully now you understand that my pods will not be reachable outside my node cluster. So they will only be reachable from my single node cluster, right? So let me clear my screen. So for example, now we are trying to assign one particular IP address which we can do curl on, and then we will be getting a response back from one of the pods, right? So just think about the load balancer analogy, which is sitting in front of all those particular pods which are created as a part of deployment. So let me try to do that. So what I am trying to do here is, so before I do that, so we already know that we are basically running 3 pods as a part of the deployment. So you can see that I am basically exposing a port 8080, and my target port. So the target port is nothing but these are the ports which is open from the Nginx pods which are running as of now, and my and the port which I am exposing the service on is nothing but 8080, right? So let's try to do that. So you can see that now the service is getting created. So let's try to list our service which we have just created now. So now you can see that there are 2 services. So Kubernetes is one of the service, and we have just created this Nginx deployment. So now you can see that one of the IP address is already assigned to our deployment, right? So if I try to so again from my node, if I try to do the curl, let's try to do that 10.108.199.49. So again, I will not be getting any kind of the response back from my base machine. So these particular cluster IP can only be reachable from the node or from your cluster itself, So let me try to log in once again. Again, I will be logging to my node once again. So just give me a sec. So Control C. So now I have logged into my node once again. So again, now I will try to curl once again. So let's try to do curl 10.108.199.49. So I have not really mentioned the ports, so for that reason I am not getting any response. So sorry about that. So you can see that we have already exposed a port. So we have gotten a response back from one of the pods, but we don't know which particular pod has responded. But we have exposed the service, and which is already reachable from my single node. So that's what I really wanted to explain at this point in time. So if I try to exit from my node, I will clear my screen. So let's try to describe our service, because we really wanted to explore some of the properties related to the service. So I will just describe. So you can see that the name of the service is Nginx deployment, and the namespace is nothing but default. And you can also see the cluster IP address, which we basically made a use of, and where we have exposed our service. So you can also see that Nginx server is running on the port number 80 on these particular endpoints or IP addresses for that matter, right? And so now we are at the last part of our, so for example, if we really wanted to delete a deployment, we can basically make a use of this particular command. So I'm just deleting my deployment, and similarly kubectl delete service, again Nginx deployment. So I made a typo there, because in my next demo I will not be needing this, so therefore I am just trying to delete the deployment and service. And so that's it from current video, and we'll see you in the next. Hello all. So in this particular section we are basically looking at creating a node web application. So I will be using following commands, and you can also see the GitHub repository in which the application code is also hosted. So if you really want to refer that repository, please feel to refer. So without any delay, I will be moving on to my terminal. So here, if you can see that my present working directory is k8s and k8s web hello. So if I try to list, you can see that there is a Docker file, and there is also the index.mjs file, right? So before I do that, I just wanted to show you what is the code that is there in the index.mjs file. So please feel free to refer this particular code. So this is a very simple application. So you can see that this is the code. We are using a code which is nothing but 3000, and it is simply returning a message hello from let's say Ubuntu, right, which is our base machine. So if I go back here, and I will go to my Visual Studio Code. So here you can again see the same file here. So now I will be following the series of the commands. So just give me a sec. So I have already created this particular directory, and I have also created this particular directory. So please feel free to clone this particular repository if that makes your job little easier. So now what I really want to do is I just wanted to check the current version of the node. If I do that, you can see that this is my current version of the node. If you have not really installed a Node.js application, please do so with the help of the the application package manager. And now I will be basically and you also need to install npm for that matter. So now I am just trying to initialize my directory. So you can see that package.json file is getting created. And if I might go to my Visual Studio Code, I can see that package.json file is getting created when I try to initialize my current directory. So once I did that, now I will be installing Express application. So let me go back to the terminal, clear my screen, and so let's do that. So it will take a minute. So yes, I think we have successfully done that. So if I go back here, you can see that there is one more file which is created now. So this is what I really want to demonstrate in this particular video. So in the subsequent video, we'll be looking at how to Dockerize the containerized application, right? So see you in the next video. So good afternoon, guys. In this particular section, we are looking at Dockerizing our node application. So let's start with the understanding. So for example, if I move back to my if I try to ls, you can see the Docker file is already there. So let me try to open our Docker file. So I just wanted to give you a little bit of the understanding of the Docker file which we are using. So you can see that we are basically using alpine Docker image. Then we are trying to set our working directory, which is nothing but application. and then we are trying to expose our port, which is nothing but 3000, and then we are trying to copy these particular files to our current directory, which is nothing but application, and then we are trying to run a command npm install, and then we are trying to copy the remaining files to the current directory, and then we are trying to execute a command npm start. So let me get back to this, and if I go back to my so for example, before I then now we have got a little bit of understanding of the Docker file, how does it look like, and we basically need to make a little bit of the modification into our file. So I need to modify a little bit our package.json file. So you can see that in the script section we basically need to modify a little. So I will just mention start, and here I just need to mention our index.mjs file, so which is already I have already mentioned for the reference purpose. So if I make this particular modification and I save that, I think we should be good. So if I go back here, now we will try to build a Docker image. So we will be referring this particular command for that matter. So let me move back to my terminal, and so just remember, so this is my present working directory, which is nothing but k8's web hello, and you can see these are I have Docker file with me, and I have also got application related files. So let's try to run this particular command, and we will be building a Docker image. So you can see that Docker build, and this particular dot represents the current directory, and then -t basically represents tag. And so this is my Docker Hub account, CyberSec Nerd, and then I'm just trying to name an image k8's web hello, and I'm not specifying any kind of the tags, so by default it will by default the tag will be latest. So let's try to build an image. So it will take a second. So we have successfully built our image. So let me clear my screen. Docker images. So let's try to list all the Docker images we have had. So you can see that we have successfully built the Docker image CyberSec Nerd K8's web hello. So let me clear my screen. So the next step will be we will try to push this particular image to the Docker repository. So this is my So login has been succeeded, and now I will be pushing my image to the Docker Hub repository. So it will take a second. So you can see that our image has already been pushed. So let me move back to my Docker Hub account. And if I go here, if I try to refresh this particular page, so you can see that this is my repository. So if I click on this repository, and if I see that, you can see that a tag is latest because I have not explicitly specified any tag. So this particular image has already been pushed to the Docker Hub repository in my account. So 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 I will see you in the next video. Hello friends. So in this section, we are basically looking at how to create a deployment using a custom Docker image, which we have already pushed to our Docker Hub repository. So if you are able to recollect my our previous demonstration, so we have successfully built an image and we have pushed to the Docker Hub repository. So let's try to do that. So first command I'm going to execute is kubectl get deploy. So you can see that we are trying to list whether we have any kind of the deployments on our single node cluster or not. So we have successfully identified that there is no deployment in the default namespace as of now. So similarly, I will be checking whether we have any kind of the services running or not. So you can see that we have only the default Kubernetes service running for us as of now. Apart from that, nothing. So let me reference, sorry about that. Yeah. So let's try to create a deployment using our custom image. So here, if I go back to my repository, you can see that I will be making the use of the version 2.0.0. So let's append that v2.0.0. So I will be copying this particular command and let me paste it. So you can see that a kubectl create deployment. So I am naming the deployment nothing but k8's web hello, and the image which we are using is this one, right? So which we have already pushed to the Docker Hub repository. So the deployment is created. So if I try to list my deployments now, you can see that we have one particular deployment running as of now. So the second subsequent steps, I'm just going to, since we have already created a deployment, let's try to see whether we have a pod running or not. So you can see that as a part of the deployment, so this is the pod which has already started running. So this is the hash which is corresponding to the deployment which we have created, and this particular hash value corresponds to the pod which is getting created as a part of our deployment, right? So moving back, so now I will be exposing a service. So before I do that, I just wanted to show you once again. So if I move back to my Visual Studio Code, so if I go back to my the application code, so you can see that we have exposed the port number nothing but 3000. So it's very, very important to remember, and we are going to expose our application on the same port. So moving back, so let's do that. So I'm just trying to create a service, and you can see that we are trying to expose our deployment on the port number which is nothing but 3000. Now if I try to list my service, so let's say SVC, so you can see that so let me clear my screen and run the command once again. So now you can see that there are two defaults, there are two services running in our default namespace as of now. So the second one is a default service Kubernetes, and the first one which we have just exposed as of now. So you can see that this is the ClusterIP. So we will be using this particular ClusterIP in a bit, right? So in the previous demonstrations, we have already looked that from my base machine, I will not be able to establish a connection to the pods which are running inside the Kubernetes cluster. But however, if I try to log in my single node minikube, I will be able to establish a connection with the Nginx server. So let's try to do that. So now what I'm trying to do is I'm trying to log in. Before I do that, I can also do minikube IP. Just to see what is the IP address that is allocated to my single node cluster, and then I can run this particular command to log in or to establish a connection with my single node. So I have already logged into that. So if I try to do curl, and for example I will be making the use of the cluster IP address which you can see 110.12.24, and we have exposed the port number is 3000. So if I try to do the curl, and I made a typo, so sorry about that. So if I try to do the curl, you can see that I have got the message back, right? So that does mean that whatever the custom image we have pushed to the Docker, and we are basically referencing that particular image to create a deployment successfully, and we are able to establish a connection to this particular pod which is running, right? And we have exposed the service at port number 3000, and if I try to do the curl, I have got the response back. So this is what we intend to cover. So in the subsequent video, we'll be looking at how to scale the deployment. So see you in the next. So friends, in this particular section, we are basically looking at how we can scale custom image deployment. So in the last video, we have successfully demonstrated how we can scale our custom deployment. So let me try to, for example, let me get to my terminal. So here, first of all, I will try to list the deployment. So from the previous demonstration, we have already seen that we have got one particular deployment running. So similarly, kubectl get pods. So you can see that as a part of the deployment, there is only one pod running as of now. So let's try to scale our deployment as of now. So I will be running this particular command, and let me go back to the terminal. So now you can see kubectl scale deployment. So I have just mentioned the name of the deployment and I have given replicas as 4. So we'll be creating 4 pods. So you can see the deployment has already been scaled. So kubectl get pods minus o wide. So if I try to list the pods once again, you can see that we have successfully scaled our deployment, and you can also see the IP addresses allocated to the pods which have gotten created, right? So for example, you can see this is the hash of the deployment followed by hash of the pods, right? So let me clear my screen and run the command once again. So you can see this we have successfully scaled our deployments. Now we can see as a part of the deployment there are 4 pods running as a part of the deployment. So now what I really want to do is so we will try to do the curl once again, and I will try to list the service once again. So in the previous demonstration, we have successfully created a service. So there is a cluster IP address that is getting allocated to our node, which is nothing but minikube. And when we try to do the curl at the port number 3000, which we have exposed as a part of the service, we have gotten the response back. So we'll try to check the same thing, and we will try to make sure whether we are getting a response from all the 4 pods, which constitutes our deployment, right? So let me, so I will again try to establish a connection with my node, as we have already discussed previously that I can only be able to successfully establish connection to the pods running from my single node, not from my base machine Ubuntu, right? So now what I'm trying to do is, so again, just give me a sec. So let me clear my screen. Let's try to list our pods. I would like to list service as well, so as to remember my cluster IP address as well. Now I will try to establish a connection with our node, right? So we have successfully done that. So now I will do curl 10.110.12.24. So this is the cluster IP address allocated to our single node cluster. So, and we already know that we have exposed the port 3000 for our service. So let's try to do curl. So you can see that we have got the response back. So let me try to do this once again and go. So if I try to do that, so you can see that the first message I got from this particular pod, which ends with D4, and the second response I have gotten back from the second pod. So now we can successfully we will try to make sure that we understand this completely. So if I do this, so we have got response from this particular pod. If I try to do this once again, you can see that I have got response from the different pod once again. So that does mean that we have successfully scaled our deployment, and with the help of the single cluster IP address allocated to our single node, we are able to successfully retrieve a response from all the pods which are running as a part of the deployment. So see you in the next. Hello all, in this particular section we are basically trying to demonstrate a difference between cluster IP and NodePort if we are trying to create a service in front of our deployment, right? So in the previous demonstration we have made a use of the default service which was making the use of the cluster IP. So I will try to give you a demonstration which will make the difference between the two very clear. So if I go back to my terminal, the first command which I am going to run is get deployments. So you can see that there is a deployment which is running as of now, and which is nothing but K8's web hello. And if I try to list my pods, you can see that there are 4 pods which are running. You can see the hash of the deployment. You can also see the hash of the pod, which will get deferred from every other pod which is running as a part of deployment. So if I try to list now service as well, so just give me a sec. So you can see that there is only a service which is running as of now, which is a default Kubernetes service. So if I try to, so let's create one more service. I will be making the use of my notepad file once again. So this is the command which we have used in the previous case, and let's see what it does. So if I try to run this particular command, you can see that we have exposed a port 3000 uh, on our deployment, which is nothing but K8's web hello. So if I try to list these services now, so you should be able to see that we have created this service K8's web hello, and you can see that by default the type is cluster IP, and this is the cluster IP address which is getting assigned to the service. So let me clear my screen. So again, here, so for example, if I try to do the curl in one of the pods using the cluster IP address, I can do that. So for example, if let me establish a connection with my minikube single node. So now I am inside my minikube. So if I try to do curl, and I will be making the use of the cluster IP address 10.100.143.165, and I have exposed the port number to be 3000. So let's do that, and I will just echo. So you can see that we have got a response back from this particular pod, right? So if I try to run this particular command once again, so let's do that. So you can see this time the response we have gotten from this particular pod, which is different as compared to the previous pod, right? So our deployment is running successfully now. So just remember that we are doing curl, and we are making the use of this cluster IP address, which we can see it here, right? Now, and so now I will exit from here, and I will clear my screen. Minikube IP. So just remember, so this is the IP address which is getting allocated to my single node. So now if we try to do the curl, we will be making the use of my minikube cluster IP address, right? Not the cluster IP address which we have seen while we try to list the service. So just remember that. So first of all, kubectl get svc. So we will be deleting this particular service, kubectl delete svc. I would say K8's web hello. So now my service is getting deleted. If I try to list the service, you can see that that particular service is no longer available. So now what I am trying to do is I will be making the use of this particular command, and here I will be explicitly mentioning the type as NodePort. Can you see it here? So if I try to, now my service is getting created. So for example, if I try to list my service, now you can see the cluster IP is also getting allocated to my service, but at the same time you can also see that now the type is nothing but NodePort, right? So now what I'm trying to do is, so for example, if I try to establish a connection, just give me a sec. So now I'm trying to establish a connection with my NodePort, because I will not be able to establish a connection from my base machine. I should be inside my single node, then only I will be able to get a response from my pods back, right? So now I have already established a connection with my single node. You can see that so I am in this particular machine 192.16.49.2, right? So if I try to do curl here, so just see what I'm trying to do, curl, and this time I will be basically making the use of 192.16.49.2, and I will also be making the use of the higher port. So can you see this? So when I created a service with the type node port, I am also getting allocated with a higher port 32098. So let's make a use of that particular port. So 49.2, and I will be making the use of 32098. So echo. So just give me a sec. I mean, if I try to do curl once again, 192.16.49.1, 32098. So this is the higher port. something is not perfect. Just give me a sec. We'll see. If I try to exit from my single node cluster, if I try to log in once again, I will clear my screen. Host name -I. If I try to do that, so if I do curl, I will be making the use of 192.168.49.49.2, and our port is 320.98. So so this time I am getting a response back. Can you see it here? So we are basically making the use of the IP address which is assigned to our minikube cluster, and we are basically making the use of the high level port which is automatically getting allocated when I try to create a service with a type node port, right? So you can see that I am getting a response back, right? So this time I am getting a response back from this particular pod fm4qw. So again, if I run this particular command, probably this time I have got response back from this particular pod. So this is what I really wanted to demonstrate, and I will see you in the next, where we are trying to create a load balancer as a service. Hello friends, in this section we are basically looking at creating a load balancer as a service. So let me get back to my terminal once again. So before I create any service, let us list our services. You can see that this is the NodePort service which we have created in the previous demonstration. So let me delete that particular service. I would say k8s web hello. So that particular service is getting deleted now. And if I try to list once again, we have just got Kubernetes as a default service. Let me clear my screen. So now if I try to make a use of this particular command, so nothing has changed in this particular command. Only in the type I have mentioned load balancer in place of the node port. So let's do that. If I try to list my service once again, you can again see the similar kind of the thing has happened. So for example, the type is load balancer, and the cluster IP address is also getting allocated to my service. And in the external IP, you can see that it is pending. So for example, if I were to run this particular command, and if I were to use EKS as a service on AWS, Elastic Kubernetes service on AWS, so I will also be getting the public IP address assigned to my this particular service, which will be acting as a load balancer. Therefore, my service will be available for the internet at large. And similarly, you can also see that one of the higher level port is also getting assigned to this, right? So the behavior is quite similar, but when we are trying to use load balancer as a service, just remember that one of the public IP from one of the cloud service providers will also be getting assigned. For example, if you take EKS on AWS, or GKE on GCP as well. So this is the only difference. And if I try to if I log in into, let's say, my node port, and if I try to do the curl, I can still do that. So I logged in here, and if I do let's say curl, and I would say 192.168.49.2, and higher level port is nothing but 30704. So you can see that I have got the response back from one of the pods which are running as a part of deployment. So the thing remains same. Let me exit. So everything remains same. Just remember that when we are basically making use of one of the cloud service provider, we will also be getting assigned one of the public IP address from the cloud service provider, and our service will be we will be able to reach out to our service from the internet at large as well. So that's it for this demonstration. Let me see you in the next. Thank you.